Hello, guys. Welcome to Physics TV Global. I hope you all will be fine. First of all, I would like to thank you all for your great response on my previous video. In this video, I gonna explain the macrometer or the screw gauge. And I am pretty sure that after watching this video completely means that if you didn't miss any part of it, then I can assure you that you will be able to know well about the macrometer and the screw gauge. And you will be able to analyze well that why do we need this device. And you will be able to know what means of least count is, how we can find the least count of the macrometer, and all about it. And you will be able to know about all its parts and their functions separately with the help of animations simulations activity, and you will be able to take the readings from main scale and from circular scale, which is also called thimble, with the practice of simulation activity, and you will be able to know well about the zero error, where this error exists and how we can find in this device zero error, and how you can remove it after simple calculations. And furthermore, I will also take some questions from past papers to explain it well to make you perfect in this topic. But but you have to watch the video completely. So let's move towards the whiteboard. Dear students, first of all, I would like to explain the first part of the objective, that why do we need a macrometer or a screw gauge. For this, we just need to know one terminology that is called the least count. Least and count. So as you can understand from the combination of these two words, the first word means the least means minimum. Count means measurement. It means that we are going to look the something which is the minimum observed value, minimum the measurement of what, who is going to measure, who is going to give us provide the minimum value or any measurement. Of course, the device, any device, it can be any device, instrument. So it means now I can say that whether if we need to see that what is the minimum capability of any device, of any instrument, what is measurement, that is called its least count. Okay, now just for example, see this the way you use very frequently the millimeter rule in your and daily on a daily basis in the classrooms, the millimeter rule. So what is the what you think, what is the least count of the millimeter scale? So very simple it is, as you know, that till 1 centimeter. This is these are the centimeter, and till 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. After 10, we have 1. What 1? 1 centimeter. It means that 1 centimeter is going to split into the how much? Into the 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this is 1 centimeter. So then what about this? I think you know it. This is the millimeter. 1 millimeter, 2 millimeter, 3 millimeter, 5, 7, 8, 9. And when 10 millimeter, we know that 10 millimeter is equal to 1 centimeter. It means that what is the minimum capability of this device for its measurement? Of course, the 1 divisions. Okay, so in this calibration, you easily can get to know that what is the least count of this device. This is how much? 1 millimeter. Now, what about this meter rule? We use also very frequently in the science lab. Okay, so here also we know that the calibration, this calibration with the divisions, whatever we have on here on the millimeter scale, same calibrations we have on the meter rule. So what is the difference? just the range. It has range 15 centimeter, but here meter rules always have how much? 100 centimeter means equal to 1 meter. That's why we used to say this is a meter rule. But so what will be the minimum capability? Means that the proper word, the physics word we will use, what is the least count of this one? So its least count will be also how much? Think and tell me. Of course, same. It must be same as the calibration is same. So it also has 1 millimeter, the least count. Alright, if we take another device, for example, you know about these devices very well, the wristwatch. So in the wristwatch, what can be the least count? What is the minimum capability of that wristwatch? How much it can measure minimum? We know that it gives us three things. It gives us seconds, it gives us minutes, okay, it gives us the hours. So which is the minimum? This one. And then in the seconds, what the minimum measurement it can gives? It gives, we know that it gives a 1 second. Okay, so because by this device is minimum capability of its measurement, or the proper words of physics we will use that word, that the least count of this watch is how much? 1 second. All right, but yes, of course it change. If we focus on the different types of watches, like the this stopwatch, and the different types of stopwatches we have, so it depends that. So we have to focus only that what is the least count, what the watch you have in your hand, then you easily can analyze that yes, this is the least count. All right, now if you see this device, oh my God, this is a different thing. Oh, what this is? We know vernier caliper, vernier caliper. Okay, so what is the minimum capability mean? What is the least count of this one? The least count of the vernier caliper, directly I'm telling you here, is zero point 0.1, because the next video after this, right after this video, inshallah, after a few days, I'm going to make the video where I will explain well what is the vernier caliper in details. So don't forget to watch my next coming video. Inshallah, you will there understand well about the vernier caliper. So here just I'm giving you the example that zero point 0.1 what millimeter. Before this was 1 millimeter. The meter rule was 1 millimeter, and millimeter rule was also having 1 millimeter. If I say the measuring tape, okay, also 1 millimeter. So but if the thing is smaller, if its dia is equal to zero point 0.1 millimeter, then how we can measure? Then this device helps us. It means here the thing where we have to focus that the least count of this device is zero point 0.1. Mean if the object which is concerned object, and we want to measure its diameter of the length, if it is till zero point 0.1 millimeter, if the size is till zero point 0.1 millimeter, we can measure it with the help of this beautiful device. But now come to the main point. Okay, our objective. What is our objective? Our objective is that if we have the object, if the object is what? That its dia is means less than zero point 0.1. It's measure zero point 0.1 millimeter, but it's less than zero point 0.1. So if that is less than zero point 0.1, then what does it mean? It means we cannot measure the dia of this copper wire with the help of any meter scale, rather it's a millimeter at a meter rule. It is the measuring tape, it is a vernier caliper. We can't measure it. So it means we need another device. Yes, it means we need another device which is more sensitive than this, which has the more capability to measure the least value much lesser than this. Then we can measure the objects like the copper wires, like the strings, whatever mostly we use in the physics lab. Okay. So where we need to measure the dia of the strings, dia of the copper wires, and different types of wires we use for the different purpose. Okay, so for that purpose, for that, how you can achieve that objective? Very simple. For that task, physics help you. Okay, what? That we use the device that is called macrometer. Macrometer are also called screw gauge. Screw gauge. Screw gauge are the macrometer. So it means that we have discussed before. So what is the least count of this one? First, let's listen only the least count, then I will explain how we can calculate it. Okay, it's least counted 0 point before it was the for vernier caliper point 1, this is 0.01. So what is the difference? For the vernier caliper it was zero point 0.1 millimeter. What does it mean? It means 1 over 10. It means that if we have means the 1 millimeter line and if we divide 1 millimeter into 10 parts, then one part one this the distribution, okay, one segment we easily can measure with the help of a vernier caliper. But just look over here in the macrometer. What is this? 1 over 100. Oh my goodness, 1 over 100. It means that if you have 1 millimeter and if you divide 1 millimeter into how much parts? Into 100 parts. 100 parts, then just imagine what will be the one part, how much it will be very small, like a string, like a wire, even like a hair. Then this device helps you to get to measure easily, to get the dia, to get the length, whatever it is concerned, what you are going to do at any time. So this will help you to measure the diameter or the length of any object which whose dia is exactly 0.01 millimeter. Okay, all right. Now after this, just concentrate, listen carefully how we can get this 0.01 millimeter. Very simple. Least count. So for finding the least count, we have the equations, we have the formula. Okay, I'm not going to detail how we get these equations, but directly just I will tell the least count. What is the equation? Its equation is pitch divided by total number of divisions on what? On the circular scale. On circular scale. I will explain later. As you can see, this is the main scale. All right, and this is the circular scale. It has two scales, combination of the two scales. Okay, that I will discuss later with the help of diagram and also with the help of the simulated activity and animated video. Okay, so just watch till the end so that you can learn well. You should be the best in the macrometer concept and this is the well utilization and all about its calculations. Okay, come back to the now. So this is what the total number of division on the circular scale. This is very simple. Why simple? Because we know that. Okay, if I show you here the diagram, say here, this is the circular scale. Okay, circular scale, and the circular scale is also called thimble. So circular scale, it has also how much? 50. Look here, 50 total 50 divisions, 50 line. So no units here, just we have the number. This unit with the number, no unit and the number with no. Okay, so the numbers starts from means reference 1 2 3 4 5 6 and so on till 45 46 48 49 and till 50. Okay, so total divisions mean this circumference, this circle, it is divided equally into the 50 parts, 50 divisions. Okay, so keep in mind the micrometer what we use in the Cambridge, it has a 50, but yes, in the market also there are the micrometers where you also can see the 100 divisions. But don't go away, I think here no need to go over there. But yeah, of course, if it will be 100, then here we divide by 100, and what will be happen? That will be the more sensitive. The least count will be less than this. Okay, so that no need to discuss over here. But you must know about this. That mean it not necessary that always this is 50 divisions. But yes, regarding to the camera, regarding to IGCSE and AS A levels, especially AS practicals, here what the we use macrometer that has a 50 divisions. Okay, all right, so this thing has finished, that we know this value, we know. So what about this page? What is this page? To understand this page, listen carefully. It's a little different. Okay, so let's listen. What is the page? Dear students, the pitch is what? The pitch is what? It is the distance covered. First listen the definition and try to keep in mind. Distance covered by what? By the circular scale. By circular scale after one rotation. Mean if you give one rotation to the circular scale, how much distance is covered on the main scale, on this scale, okay, that is called the pitch. Listen once again. The total distance covered by the circular scale after one rotation, so how much distance is covered in the millimeter, whatever the result will get, this will be called the pitch of the macrometer. Okay, so let's see how we can find the pitch of this macrometer. So when we give rotation, again, I will show you this rotation in the this simulation activity. Just listen now here. Wobbly you can first you need the basic concepts. So when we give the, if I say the distance covered for one rotation, distance covered by one rotation. Okay, so when we give the one rotation to the circular scale, starting from the zero, of course, when they are close together, then what happens? We see that how much distance is there in millimeter? Zero. Oh my God. This is the problem. So if the zero we cannot find, means zero over some zero over this pitch over something 50. Okay, this will be what? I mean the zeros. That's why it means we cannot find it. So for this, it means we have to use another technique. And it's very simple. What is the technique to get the distance covered? To find the pitch? So we give the another rotation. So when we give two rotations, so I can say distance covered by two rotation, or what? Of circular scale at the thimble rotation. And this is how much? This is, then we see only one line, one division. After zero we see the one division, one line, 1 millimeter. It means that, so 1 millimeter the distance for the two rotations. What do we need? We need distance for the one rotation. So I think you got it. What is the pitch? So what will be the pitch? I mean the distance of the one. So we will divide 1 by 2, 0.5 millimeter. So this will be what? This will be the distance covered by the one rotation. It means this is the pitch. So you have succeeded to find the pitch of a macrometer, given macrometer when we have 50 division. So what it is, as I said before, here what is the equation? Pitch over total division on the circular scale. So how much it is? Now this is the this one 0.5 the pitch, and how much? 50. Okay, so after simplification we will get 0.01 millimeter. Okay, so this is the least count of a macrometer or the screw gauge. 0.0 is the constant, you have to memorize it. And also you should know how we can get and calculate, and if the number of division change, how we can calculate it. So you know the method very easily, very quickly. You can get whatever the device you have in your hand. But as I told, in the Cambridge we use only where we have 50 divisions. Okay, let's go ahead after the least count of the macrometer. Okay, so it means that now we can describe what is the macrometer. So it is the device, okay, whose capability, whose least count is 0.01 millimeter. Means, so we can say the measuring device. The measuring device whose least count is 0.01 is called the macrometer. Alright, after get to know the definition, now you need to understand is parts one by one and they're working. So first part is the same thing, what this main scale, this part main scale. Here you can see starting from 0 till 25. So for understanding the main scale, this is main, it's very important, and Julie students get confused. So listen carefully what I'm going to explain. I will make it very easy for you guys. Okay, see, look over here. This, now I just got the diagram. This is the main scale. Okay, what I showed you before, this one, this thing, okay, over is over here, but till only 5 6 7 till 8, but totally it is till 25. But here just I cut it the one piece, okay, just to make you understand, till the 8 degree, till 8 millimeters, sorry, 8 millimeter. Why this 5 6 7 and 8 millimeter part. Okay, so what is here the first important thing on the main scale is what? This red line. Please never forget this red line and keep in mind to understand well about the macrometer, its use, its calculation work, that this red line is what? This red line, my friend, is called the reference line. Okay, reference line. This red line is called what? This reference line. Mean the line which can say the line above and below it. There are the graduation, there are the calibration. You can see above the upper side of this red line there are the calibration, and the lower side also we have the calibration. The divisions are there. So what is that? It's making it complicated, but it's not complicated. Okay, why? Let's listen. So the calibration which are above the reference line where you have the proper numbers, means 0, 5, after 5, after this will be 10, and then 15, then 25 till 25, the last number, the maximum capability of the macrometer, 25 millimeter. Okay, so till here, and now, so that is called the main calibration. Main calibration. How you'll get to know this is the main calibrations? When you have the proper numbers, mean just say 0, then here number is not mentioned, no problem, you can count 1, 2, 3, 4, 5. So it means that is the 5 divisions, 5 number is given, it means 5 millimeter. So this is the proper calibration. But if you just look down, see, this is the reference line, okay, and this is the one. So this is in between, then this is second, from 1 till second, then in between the center we have the 1 divisions. Okay, so it means that what, if this here's a 1 and this is what, and at the center it will be half. It is half. So if this is the half, what do you think, what can be the value? If full is 1 millimeter, what will be the half, its center? Exactly, I know you got it, that this will be the zero point 0.5 millimeter. It means that the calibration above the reference line, they are the proper numbers, 1, 2, 3, 4, 5, 6, 7, 8, and so on. But here, this is 0.5, my friends. 0.5, 1 is 0.5. Okay, so here this 0.5, this will be also 0.5 plus 0.5, it will be 1, 1.5, and so on. But keep in mind, usually we take 1 at one time. So you keep in mind that the lower line, lower calibration, lower deviations from the reference line, that is equal to 0.5 millimeter, also called the fractional part. Means you can keep in mind that the lower part of a reference line is called fractional part. Fractional part means it gives the value in the fraction, that is 1 division is equal to 0.5 millimeter. I think you got this. What is the main scale? Now we need to go ahead. Not good. First, I want that now you just should learn over here that now whether what is the value over here. How we can see what is the value, what is the visible, because when we close the macrometer, when we closed it, okay, all the numbers they will be invisible. Okay, it will overlap, the circular scale will be overlap the whole main scale and we cannot see any numbers. But as we'll adjust the object, how this, again I will show you in the video in the simulation activity. So there, what the deficiencies will be over here, that will be removed in that activity. So now see, just focused on the value, the results. What is the results over here? So what I said, the visibility, how much visible, how much lines, how much readings are visible. So we can see visible, 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 and visible. And this is 8, we have discussed before. 8, what 8 millimeter. And after 8, is there any division which we can see in the fractional part? No, there's a no division. It means that what will be the main scale rating? What is the main scale reading over here, which is the visible, which you can see, that all you have to count what you can see. So this is 8. So the main scale reading will be very simple, 8 millimeter. Okay, now just I'm going to now in this here the second, now means the diagram. Here you'll see there's a little difference. What is the difference? I think now you can get by yourself. This is 0, 1, 2, 3, 4, 5, 6, 7. After 7, no 8 is there. Like here, it was 8. So after the 7, till here, I stopped till over here. Okay, this was 7. Okay, so the half part of a this is not the part of a observation of the observed value. So it means you will stop over here. So this will be the 7 millimeter, and after this, always we have to look down rather there's any deviations below the reference line, as when we observed over here there was a no divisions after this 8 below, so it was the 8 value. But here if when we say after 7 there's a one line, so this is zero point 0.5, this is 7. So what will be the value of mean scale reading, my friends? Think. I think it's very simple. Very simple. So it is 7.5 millimeter. Okay. It means that now I can say that easily you can find the value from the main scale very quickly. Rather it's carry the fractional part. Rather it doesn't carry. Easily you can find. But yes, here if I give you one tip, like for example, means after this mean suppose it is over here, mean this line is not visible, then what you will do here? Okay, then here what we have to do approximately, look, you have to, like this is the 7, and so this is not the zero point 0.5, so you can take 0.2, 7.2, you can take 7.3. Okay, so this is the I mean estimation you can take. It is acceptable in the Cambridge exam. All right, so but usually does it happen? There's another technique also we can fix it. I mean if we give a little rotation more, even the object is inside the studs, okay, then we can bring it to the proper value. But no need, whatever it is, okay, just take the value as I told you. If proper, give the proper value. If there's some little, you can make the little bit estimation. All right, now go ahead. Now we see the how we take the circular scale reading second, because this is the part, this is the device which are what, which have the two, like the two scales it has, one the main scale, one the circular scale. And another important thing is what over here, that we have here the reference line, reference line. All right, now just see very quickly, you can take the value of the main scale. This is 1 2 3 4 5 6 7 and 8 at 8 millimeter. So here our objective is not to find the main scale, just I give you the review, okay, because you can find it. So it is 8 millimeter on the main scale reading. Okay, let me write main scale reading, it is 8 millimeter. All right, I need no circular scale reading. I mean thimble, this is circular scale. Okay, so here what we say, you very simple, just you have to see that which number is just in front of the reference line. Okay, which number is coming, that here suppose we can see that this is the 10, that's 11, this 12. 12 is just in front of this reference line. So whatever the number of the circular scale is in front of the reference line, that you will take. Okay, so again, so now please you help me think about it. What can be the circular scale reading? Count on. This is in the, the increasing form, so you have go in the upward directions, 10, 11 and 12. So it means this is what, 12. 12 what, millimeter? No, no millimeter. Never mentioned the 12 millimeter, because I told you before the divisions. Okay, so but we need the numbers with the proper unit. So what you will do? So here it means what you will do, you will just multiply it with its least count. So it will be the 0.12 millimeter. What the value of a circular scale reading? It means that here the one division is equal to how much? 0.01 millimeter. Rather you count like this, but it is very difficult if you add all this 0.01. Okay, just take what the number you have in front of this. Okay, and very simple, just so this is the division to convert it into the with the proper unit. Okay, then and with the proper physical quantity, then you just multiply it with its least count, then you will be able to get what the values over here. Okay, so for the final, if we are finding the diameter, we will add both main scale reading plus circular scale reading, just add both of them. 8 plus 0.12, so it will 8.12 millimeter is the measurement. Okay, after adjusting mean in the object in the between the studs. Okay, and mean in the device, I will show you later what the studs are, the how we adjust the object. But here just I'm telling how we can take the readings from the circular scale. Let's see one example more. I think now you can do by yourself. Look up this now, the second diagram. Okay, here. Oh, all right. What's the problem? Okay, so okay, look. 5, 6, 7, and here we get 7.5. Just for practice, main scale readings. Okay, you are now you can easily find main scale reading. How much? How much it was? 7.5. Because after this 7 we have one division in the fractional part, the lower part below the reference line, 7.5 millimeter. All right, so our here task is to do the practice of circular scale reading. Circular scale reading. Okay, okay, let's see. So go up. It's 20, 21, 22, 23, 24. So 24th line is just coming, just parallel, coinciding, okay, towards to the reference line. It means, so what is the value? So circle scale will be 24. Or directly you can write 0.24, because when you multiply the least count, it will be 0.24. So you can skip this this step also. Just mean directly you can write this one, but better. Okay, if you want to save yourself from the mistakes, just count the divisions. It was 24, multiply the least count, so this will be your the value of this one. So what is the total reading? The result, whatever we're doing, the length of the dial, just add both of them. 7.5 plus 0.24, it will be 7.5274 millimeter. All right, so very simple. So this was how we can take the readings from circular scale and the reading from the main scale. All right, now just see, have a look, and just look on the parts, different parts. Even we have this one by one, but just few others. So see, as I told, this is the stud. This here to here. This is called movable stud or spindle also. Movable, but mostly we use the word stud. Movable stud, movable or slidable, movable stud, stud stud, are also called spindle. And which is, and other side, see this one, this side, opposite side, okay, this side, this is fixed side. So that's why this is the fixed stud, fixed stud. Okay, so we place the object between two studs. This. So when we open, we get the space and we adjust the object between them, and then we take the readings. Okay, so this is the again movable stud, fixed stud, or spindle, anvil. Okay, and then here you can see what is this? The lock. After adjusting the object, we just press it down, okay, and it will be locked, so that when you're going to read when this change the position, so you're putting in front of your eyes to read out the readings of then there are chances that maybe object whatever we have placed over there between the studs, it can fall. So we just, if we lock it, it will not fall, and you can take the reading easily even by giving movement to that macrometer. Okay, and this is the circular scale, also called the thimble. All right, and it's a ratchet. What is a ratchet? A ratchet gives you that what the sound, the tick sound, tick, tick, tick. What a tick means, as here, when the object is here, when this both stud will coincide, will strike with the object, then it will produce the tick sound that yes, stop, stop over here. The object has adjusted. Okay, so when, of course, it will be adjust when both the stud will touch, come in contact with the object between them. Okay, and it will produce the tick sound. As it will produce the first tick sound, just stop it, lock it, and take the reading as I told you before. All right, after this, the last important thing, then we'll go to the simulation activity. Last, very important, where the students mostly face the problem. Okay, what problem in the exam? Rather, this is the practical exam, rather is a theoretical exam. Even in the MCQs, sometimes they use this concept. Even in the structure question, we use this concept. Okay, what about the zero error? Zero error. Okay, so what is zero error? We know that there are different types of errors. Mostly we use systematic error and random error, but that I will not discuss over here. It just I will discuss in the other video. But here, what then the zero error? Zero errors only mean connected, or it comes only, it generates only in those devices. Which devices? Which are special devices. What? Which special devices? Those devices which have at the same time two scales. Scale 1, scale 2. Okay, like we have discussed before, what in the this here in the this macrometer, there are two scales, one main scale, one circular scale. So combination of the two scales, that's why here zero error can exist. In the same way, vernier caliper also, there are the two scales, one main scale, one vernier scale. As I told you before, in the next coming video, I'm going to upload it in very few, in 2 or 3 days. Then I will also explain that in details of the vernier calipers. But here, what I mean that because that also have the two scales, so there zero error exists. So what means of zero error then? If you want to make the definition, you can make. Even it's not important definition, but you can make by yourself that the error produced in those devices which have the two scales, where two scales work together, where we get the observation from the two scales at the same time, that that error is called the zero error. All right, now come back to the macrometer. Here you can see what we can see. Here the important thing we can see that see zero of the circular scale, and this zero, what is it's not zero to the reference line, red reference line on the main scale. So if the zero of the circular scale is just parallel, just coinciding to the reference line of the main scale, then it means, oh, that's great, it's great, no error, no error, no problem. Okay, no need to do the calculation work of the error. So no error. But usually in the exam, in the exam we provide the devices which are free from the error, but not necessary. Okay, you can be provided the this macrometer via the error. So here just I want to show you that we also have a technique. Okay, physically you also can solve this problem if error is there. I mean, after if you have closed, this circle scale comes over here at that place, but still, okay, what happens that the zero of this is not in front of the just in front of the reference line, so it is error. So here we have this screw. Screw is here. With the help of screwdriver, we can give clockwise and the anti-clockwise direction to just to check. Okay, just close it and give the here the rotation clockwise, anti-clockwise, depends what we have there, positive or the negative. Okay, then easily you can remove physically also, or you can get the help of the teacher or the lab assistant during the physics exam, Cambridge exam. Okay, all right. Now come back over here. Know that if there's error, so this is the good, no error. Okay, so just move when we have the error. Let's so listen carefully. Here students face problem to understand and to work on it. So positive error, I'm going to talk about the positive error. So just look at the diagram. Okay, just see here, this is the zero, and in front of the zero there's a reference line. No, it is above. This is the reference line is over here. Zero is over here. Okay, done. It means that there's a gap. There's something wrong. There's something wrong. It means there's an error. What is that of error? Means that here, like if you see that we need to start the measurement from where? From the zero. Okay, but what's happening over here? Here we can see this is 1 and 2. It is in front of the 2. So it is starting from the 2. In spite of 0, it is starting from the 2. So when we start the reading, okay, it is not 0 but it is 2. It means 2 is what already existing. Already by default the 2 is there. Where it should be 0, mean when the it was mean one division will comes down, where it will become 3. So it is actual not 3. This will be the 1. When it will come, when excuse me, when okay, let me arrange it. So excuse me. So I was telling you that here that if, for example, I said that if it is two over here, okay, where it should be 0 but it's 2. So when we rotate it, we adjust the objects. Okay, number 1 come. So actual it 3, we will see the 3. It means this is not a 3 but this is the 1 because 2 is already there. This will be added in the 1, so it will be 3. If the second division will come, it should be on the 2. The 2 should be in front of the reference line, but it will be what? We will see it will be 4. Okay, because 2 is already there. So whenever you see that, if already you have to comes down. Okay, if you have to that mean a number, some divisions are already existing, because if you turn down one, what will be happen that It will start from 2. After 2, 3, the starting point, it will comes from 2 to 3. When you rotate in one division, it will comes from 2 to 3. So it reaches 3. So, but it actually is covered how much? One division. It covered one division. I think you got the concept. You got the concept. Listen once again what I am saying. My friend, this the reference line, in front of reference line, there's a 2. Okay, all right. So when we start to rotate it, okay, just to adjust the objects, what will happen? So when we start, the next division after 2 will come 3. So when 3 come, actually it has covered the 1 divisions. Okay, because 2 was already there. By default, it was there. By error, by mistake. Okay, that's why we can say by default the two divisions are there. So if by default mean if the value is already existing, means this is the plus, this is the positive. So that's why we say this is the positive error. What the positive error? If the division exists by itself, by default it exists, already the value exists without using, when it is closed in the normal condition, ready for the use, with before starting to utilize it, if we see that some numbers are also existing, some numbers are coming in front of the zero, I mean 2 or whatever, so we see that this is the positive error. So if this is more, this is extra, so how we can remove it? Very simple. So 2 division mean what the value? 0.01 multiply, so it will be 0.02. So this is the already exists mean the positive error. More value, it is existing already. So how we can remove it? So what is more? That just I will subtract. Very simple. For example, if the results if I'm getting 13, okay, 13 millimeter. So then after removal, what will the final result? Final result will be 13 minus 0.02, because it was already existing when we start working on the macrometer. That's why you will get what, 12.08 whatever. So this will be the millimeter, your results free from positive error. Same, just opposite thing we do with the negative error. We are not mean speak more, because here I repeated many times. So what's here? Look here. This is a 0, and here what the 0 when you comes down. Okay, I mean after one division, two division, three division. After three divisions, the 0 will comes. I mean if you have to start the 0, but it is what over here in front of 0. In the front of 0, what? This is 46. 46 will come, then 47 will come, 48 will come, 49 will come, then 0 will come. Okay, it means this is deficiency. We're going to start over here. So how much deficiency is there? The deficiency is, my friend, just count the divisions. How much divisions are there? 1, 2, 3. So 3 divisions are the deficiency. So 3 divisions means how much will be the proper value in the with the proper unit? 0.01, 0.03 millimeter. This will be the negative error. So how you will remove it? Whatever the final result you have, after after adding the main scale reading and the circular scale reading, let's suppose again if it is a 13, so then here if this is negative error, you have to plus this, because this was a deficiency. In the positive, it was extra, it was already existing. Okay, here is a deficiency, there is a less. That's why what the deficiency, just you will add it in the final result, the sum of the main scale reading and the circular scale reading. Just add this, and in this way you will get the result, which will be the free from the zero error. Okay, so this was what, how we can do the simplification, how we can get the errors, whether it is zero negative error, it is a positive error, how we can remove this error, how we can calculate the error. After this, yes, I will do I will try to make the second part of the video where I will explain, take the questions, and I will do the calculations to make you more perfect in this topic. But after this, now I think this is the time that we just should go towards where? Towards uh, the video, the animated video, where I will explain you well, just to where here if some there are deficiencies, that deficiencies will be removed by that animated video. And also at the end I will also provide you in the same video the simulated activity where you will do the practice how to take the reading. So please watch till the end. Okay, alright guys, now watch this video carefully. Here I will explain you some of the parts of the macrometer with this simulation. Just look over here that this is the U-shape framed, and in the U-shape framed you can see that what is this 25 millimeter. What is this? This is the range, the total range of a main scale. Okay, and what is the 0.01? This is the least count of the micrometer, least count. And you also can keep in mind that the value of one division of the circular scale is also 0.01 millimeter. Okay, just go ahead. That's the important part. Just say this finger is pointing what? This line, the central line, the boundary line, which is separating the above and the below calibrations. What I explained well in the whiteboard. So what is called this line? Just can you tell me? Think. What is this line? It is called. Try to recall it. This central line, the boundary line between the above and the below calibrations. Above the proper calibration, the millimeters, lower the fractional parts. One is zero point 0.5. Above one is 1 millimeter. Down one division is zero point 0.5 millimeter. So what is called this line? Exactly, maybe you're right. It's the reference line. Reference line. Keep very important reference line. Okay, go ahead. Now if I ask you what is the value on the main scale, so very simple, you easily can calculate. This is the 10, after 10, I mean, what are the visible, all that we have to measure, what are the visible in front of us. So we can see this is 10, this is 11, this is 12. After 12, if we go look down to the fractional part, there is a no value, so this will be the only 11 millimeter, 11 millimeter. Okay, all right, go ahead. Now look over here, same. Go ahead little. Look here now. So this is 10, this is 111. 11 and after 11, if we look down, there is a 1 division in the fractional part. So it means this will be what? 11.5. 11 and 1 is down below the reference line. And we know below the reference line, 1 division is 0.5 millimeter. So it will be 11.5 millimeter. Go ahead. Fractional part, zero point 0.5. Just look this, the total division on circular scale, 50 divisions. Okay guys, now just do the practice by this simulated activity. You can pause the video at different positions where the values is given, fixed values there. You can pause and you can check whether you're able to get the value of this main scale and the value of circular scale. Both values are given. Easily you can do the practice well. Pause at different positions and do the practice well. Okay, now this is the time for recapitulation. So in the recapitulation, first thing I would like to describe the macrometer. Very simple. I mean, you can say the device which has the capability to measure till 0.01 millimeter. Then its main parts, you must keep in mind all the time all about the main scale. We have discussed before in detail. Main scale has maximum range 25 millimeter, and then also you should know on the main scale that the reference line, and above the reference line there are the proper scaling mean in the millimeters, but below the reference line there are the fractional values, means one division is 0.5 millimeter. And you must know about the lock, that after adjusting the object between the studs, fixed stud and the movable stud, you lock it and take the reading from circular scale and the main scale reading. Which reading you will take from main scale? The reading which is visible in front of you, the reading division which you can see on the main scale. Just take out that. Rather, that there's a fractional value or there's a no fractional value, whatever it is visible, just take out. And for the circular scale reading, just what the value is in front of the reference line of the circular scale, that division multiplied with the least count, this will be the circular scale reading. So in this way easily you can find both the ratings. Okay, after that the last important parts is that is the ratchet or the drum also called, mean which produce the sound. So when you place the object between the studs, when the both studs will connect to the objects, it will produce a sound. So at the first tick, stop it there and take the ratings. Okay guys, thank you very much for watching the video. I am pretty sure that you will support me and you will subscribe my channel and you will like the video. Thank you very much. Till the next video.